Okay, so again, you actually have 6 ways to classify triangles. All right, so we're gonna start with number 1. Okay, so there's 6 different kinds, and you can write down whatever you think you would want to find useful for the chapter review, however, whatever you want to do. So first of all, we can classify by sides. Okay, I'm gonna write this down here. You're welcome to go follow along if you'd like. You have sides. Okay, so classifications by sides include, first of all, the scalene, which is the one we started with. Scalene means that that all of these sides are different. Okay, all different sides. Then you also have what's the name for the one that is 2 sides of a congruent? Anyone know? Say isosceles? Yeah, it's isosceles, right? And then third, when all of the sides are congruent, it's going to be, anyone know the name for that one? If all 3 sides are congruent, we call it what? Starts with an E. Equilateral. That is correct. Okay? So you can classify it by sides, or you can classify it by angles. Okay? Angles here, there's 3 ways to classify it. So you can classify it, first of all, as a right triangle. Okay. You could also classify it as an equiangular triangle. Or you can also classify it as 2 others, acute little angle, or obtuse. Acute means the angles are what? Anyone know?
Smaller than 90.
Smaller than 90 degrees, right? And then obtuse means they're bigger, right? So that means number 1 here, okay, you have 2 sides that are the same, so that would count it as an, I'm just gonna write this down here. That would count it as a, what kind of triangle, first of all? Yeah, that's right, it's an isosceles, okay? And then this one right here is going to make it what kind in terms of angles?
Right.
So that means it's a right isosceles. That's what that means. Okay? Right isosceles. All right, so number 2, right here. So again, it's a right isosceles triangle. This one right here, what would you call this in terms of the, I'm actually going to draw straws now. Call this in terms of the angle measurements, Chloe?
You're always like picked first at popsicles.
I guess so. I don't know how that works, but. So how would you classify this triangle in terms of their angles? You have 3 options, right?
Side angle side?
Well, that's for triangle congruence, but we're just looking for the type of triangle here. So are we talking if it's a right triangle, is it an acute triangle, or an obtuse? Want to phone a friend?
Yeah.
Anyone know? It's not obtuse, actually. All these angles are less than 90 degrees here. Yep.
Oh yeah, duh.
All of them are less than 90 degrees. It's not a right triangle. It's actually, it's acute. And then how about in terms of sides? What do we classify that as, Elizabeth? Which of these 3 does this triangle fall under? It's a scalene. Yeah. Because no sides are equal. So it's acute scalene. All right. So the third one asks us to use this triangle to name the following. So let's see what you remember. What are my legs on triangle number 1, Emily? ZY and YX. That is correct. So you have segment ZY and segment YX, because those are your legs. Now it's asking you to identify the vertex angle. All right, so for that one, what would be an example of a vertex angle on a right triangle? April? Hint, it's the angle with the right side.
CY.
So it's actually just angle Y.
Ah.
So B is just angle Y. So the vertex angle is just the angle that is attached to the right angle on this triangle. All right? C, what is the base of this triangle? Keep in mind it is an isosceles triangle. Okay? So the thing about this isosceles triangle is that when we picture it in terms of sides, we're actually wanting to look at it like that, if that makes sense. Okay? So what would be the base of an isosceles triangle that looks like that? Chloe?
XV.
XZ. Great. Okay? That would be correct. All right? Then the hypotenuse of this right triangle would also be what? Same thing. It's XZ. All right? Yep. What? Say that again, Chloe?
What's that? I forgot.
The hypotenuse? So the hypotenuse is the side that's opposite the right angle.
Oh.
Yep, so it's XZ.
Thanks.
All right? So far, so good. Next on the table.
Ooh.
All right. So again, let's say you have two triangles. All right? You have triangle CAB and triangle TRS. What this is asking you to do is identify the corresponding parts. Okay, so let me ask for an example here. Chloe, what would be the corresponding angle to angle C on this triangle? Yeah, corresponding on this triangle. T. Yep. And then angle A would be corresponding to angle, anyone? Angle A is corresponding to angle R. Meant that to be an R. That's a bad R. There we go. And then angle B is corresponding to angle S. Great. All right. So again, the segments similarly. CA is corresponding to TR. AB is corresponding to RS. And BC is corresponding to ST. Okay? So again, that's by location on the triangle. If it's the same distance, like picture this triangle turned around. If this is the same distance as this, ST would still be the corresponding part to CB. Okay? So that's what that one's asking you to do. Just name the congruent corresponding parts for that, which we kind of just did. But number 8 asks, if ABC is congruent to XYZ, which statements are true? And it's asking you to list all the correct answers. So, again, remember corresponding parts here. A says CBA is congruent to XYZ. Would that be considered correct? Hmm? No. And why?
Because, I mean, they're gonna have different angles.
Mhm.
I mean, it's just completely messed up. XYZ is switch.
Right, it's completely mixed up. Again, XYZ is not corresponding to CBA. Now, would B be one? What do you think, Elizabeth? Would 8B be corresponding to, would BCA be corresponding to YZX? Yes or no? Yes, it is. Okay? Because again, take a look at the pattern here. You start with B, you start with Y, okay? It goes B, C, A, Y, Z, X. Since these are still the corresponding parts in the triangle, just labeled differently, this works. Which is the other one that works in this case, C or D? C or D? It's D. Yep. D is the same on their locations. Okay, and the corresponding parts. So again, if corresponding parts match up on the congruence statement, that's what matters. If they don't match up, then it's not a correct statement. Because the location does matter for each of these triangles. Alright? Next. Now that one's kind of a tricky one. What, you guys remember what CPCTC stands for, right?
Corresponding parts of congruent angles are. Wait, no, corresponding parts of corresponding angles are congruent.
Corresponding parts of congruent triangles are congruent. So close. But again, that's basically saying that if you have two congruent triangles, their corresponding parts will also be congruent. So what it's asking for is what reason could replace the abbreviation CPCTC? The truth is, the abbreviation that could replace it, I'm just gonna put this up here because I can't pull the paper down, is the definition of congruent triangles. Because again, if something is congruent, that means their corresponding parts are most obviously going to be congruent as well. Okay? All right, I'm going to fold this piece of the paper and move on. Next. This is something I don't know. Have we worked with variables and triangles yet? At all?
Yeah,
A little bit? Okay. So, finding the measure of angle B if measure of angle A equals 59. So, how in the world do we do that?
You have to like figure out what X is.
You do. Now the question is, how do you do that? Remember the discussion we started class with. You will need an equal symbol somewhere. But how?
Since A is 59, whether something plus 59 equals 7x plus 6, right? I don't know. Because 80 and 60 were 140 were the side of 7, which is that exterior angle.
Right. So we do know that this is equal to 59. So that's our starting point. So we start there. It's going to be 4x plus 15 equals 59. That's what we start with. Because we know that to be true because we're given that angle. All right, so then we solve for x. So I'm going to subtract 15 from both sides. 4x equals 59 minus 15, which gives me what? 44. 44. So, divide both sides by 4. Bingo, x is 11. All right, we know what x is. So how on earth can we use that to find b? April?
You put it in for x, 7x plus 6, and then you subtract that answer by a and b.
That is exactly right. Again, 7x plus 6 is an exterior angle. So that means the sum of these two angles is equal to this one. So let's find this angle, 7x plus 6. So that's 7 times 11 plus 6, okay? Which gives me 77 plus 6 is 83, right? So that exterior angle is 83 degrees. So in order to find B, I now have to subtract what from 83?
50.
Yes, you subtract 59 from it to find B. 83 minus 59 gives you the measure of angle B, which is 24 degrees. It's a small angle. So again, that's why you need to know the relationships between the angles, because then you can easily identify it. So far, so good? Alrighty. A little fast? Need a moment to catch up? Number 10? Back it up. Number 10 was the definition of congruent triangles. Yes.
Thank you.
No problem. Okay, so let's take a look at 14 now. Just getting a smaller paper. So, here's your picture. Oof. Struggling here. There. Here's your picture. Find the measure of each numbered angle. Alright? So again, this is based on what you know about triangles. You know the sum of all the angles in a triangle is 180, right? So, and you're only given one angle here, 132. So, now the task is to find all these angles. So, I'm going to pull some straws here. Elizabeth, measure of angle 1 in this. Starting here. Quick subtraction there. What does it say?
48.
48 is correct. Ta-da!
Which then can't you do 3 and 1 instead? Or no, 1 and 7 because they're alternate interior.
No, you can't do alternate interior here because these are not parallel. They have to be parallel. However, notice about this triangle. What do you notice about this triangle that we could use?
Because is it all
It's not not equal angular. But what about these two sides? Yeah, it's isosceles. What do we know about the base angles of an isosceles triangle? They are congruent. So that means angle 2 is also 48. Okay?
So then you can figure out what angle 3 is.
Yeah, so what is angle 3? Hmm?
Isn't it 132?
Angle 3 is, in fact, 132. Yes. All right. So we found 3 of our angles.
And then
Which means that 4 and 5 are both 24, right?
That is correct. 4 and 5 are both 24. Because notice that this triangle is also obtuse. That's right. Oops. That's angle 5. There we go. All right, angle 6. And angle 7. Now this is kind of the tough one.
Did you just... Oh, wait, no, you gotta...
How can you find 6?
Oh, don't you add 2 and 1, and then minus...
That is correct. So you can find 6 that way.
Means 84 for 6,
84 degrees for 6. Good. And then angle 7. How do we find angle 7? We know that angle 5 is 24. Angle 6 is 84.
It's
Th-
72.
72.
I like those ones.
Yeah, those ones can be easier to put together as long as you know the 180 rule. All right, questions so far? So far, so good?
wait, how did you get 6?
To get 6? So I went back to 1 and 2, added those two together and subtracted it from 180, since the sum is 180. Yep. All right, anything else so far? All right, next. Dun-dun-dun. All right, number 17. All right. If the triangles can be proved congruent, write a valid congruent statement and name the postulate or theorem that justifies it. So this one here. Can this be proven congruent based on what's given here? How so, Emily? Side, side, side. Very good. So how would you write the congruent statement for that? Someone want to give it to me? triangle what is congruent to triangle what? ADB. ACB. Good. Are we sure that's correct though? ACB?
No.
Because which side is corresponding?
BDA is congruent to ACB.
There you go. Good. Triangle BDA is congruent to triangle ACB. That's correct. Okay, the reason why this is incorrect is, again, these triangles are mirror images. Okay? So, because they're mirror images, we have to follow the sides that are congruent. So, it goes from AD to BC. Okay? CA to DB. And then BA to BA. Alright? So, yeah, we got to make sure we follow along with that. So, the triangle congruence statement that establishes is side, side, side congruence theorem. Boom.
Wait. Wouldn't it still be the same though? Because you're.
Not exactly.
Wait, what's the issue with it again?
So, ADB is congruent to ACB. It's the incorrect location, I guess you could say. So, ADB, you're going from A to D, which is congruent to B to C.
Just think of it like you're flipping the triangle around on top.
Yeah.
You have to start in the same corner lenses. Because like these two angles are like squished in together and you flip it around. And then you have BA.
Because the first letter has to be congruent to the first
Yes. That's right. The first letter has to be congruent to the letter of the other one. That's correct. That makes sense? All right. Let's try number 20. We know that AC is parallel to DB and AD is parallel to CB. Can we come up with can we prove those two triangles congruent? If parallel, what is congruent? Not sides. We can't confirm one side as congruent. CD is congruent. However, what else do we need to know? So think about the angles. If these lines are parallel, what do we know about some of these angles?
Those angles are almost all the same.
Right. So this angle is congruent to this angle, right? Because it's alternate interior. Likewise, this one and this one. D and C. So these angles are congruent and the side in the middle is congruent. So that means we can say angle, side, angle.
I have a question.
Yes?
Technically, couldn't side, side, side be used for this?
Side, side, side. Unfortunately, no, it cannot.
How come?
Because we can't know for certain that these are the same length.
So it just says they're parallel.
Yeah, all it tells us is that it's parallel. So, yeah. So that's all we can use for this. But we do know the angles are congruent. So, angle, side, angle. So, a proper triangle congruent statement for that would be what?
C.
C?
ACD is no.
Here, let me give you one. Angle DAC, or triangle DAC, is congruent to triangle CBD. It starts on the opposite side. Because remember, we're starting with the alternate interior angles first. D and C are congruent here. And then it goes up to A for this triangle and up to B for this one. So DA to CB, CBD, DAC. Make sense so far? Okay. We're out of time right now, but here's what I'll tell you. I'm going to try... Here. Hang on, let me stop this real quick. Okay, so number 23. This is asking you to write a 2-column proof. Again, on the test, you're not going to have to write a flowchart proof. I'm not going to require it. All you're going to have to do is write a 2-column proof or a paragraph proof. So, first one is given circle P. So you're given a circle. And then you need to prove that angle PAC is congruent to angle PCA. So, again, I really find this confusing that they're giving this to you because we have not really talked about circles yet. But I will go over this proof with you real quick. 23. Oh, you can't even see that. That's not helpful. There. All right, so 23. You're given circle P. That's your given piece. Okay. Now let me see if you guys can come up with this. So circle P is given. What is something you could come up with knowing this info?
What are we even trying to prove here?
Trying to prove that angle PAC, so this angle here,
Oh,
is congruent to this angle here.
okay. I read it as triangle, so I was like, what?
Yeah, it's a little bit interesting, but what could you deduce from that picture?
Well, isn't the diameter of a circle? What is the diameter of a circle?
The diameter?
Yeah.
The diameter of circle is stretching across the whole circle between it.
Does it ever give you a specific? Because 360 is the circumference, isn't it?
Not exact. Well, as an angle, yes, it's 160 degrees. But what is this line right here? This line's called a.
What's the radius?
It's a radius. So you have two radius here. What could you say about those radius?
They're equal.
Yes, that's exactly where you need to go. So all you have to get to is angle PC, or segment PC, is congruent to segment PA. And it's just congruent because they are radii. And radii have congruent, yeah, I'm just going to put radii. They're definitely the same distance if they're radii. Okay? So since they're radii, I know that these two sides are congruent. What does that make this triangle?
An isosceles.
An isosceles. So if it's an isosceles triangle, what do we know about
My angles are the same.
the angles are the same? All right, so it's basically concluding that, well, we can actually go right to our conclusion. Angle PAC is congruent to angle PCA because of the isosceles triangle theorem. So I'm going to just do an isosceles triangle and put theorem. Three steps. Yep, that was a little bit simple. We haven't talked about circles yet, but number 27 is right here. So you're completing this proof. Okay, I'm going to draw another 2-column chart. So you are given the fact that GC is congruent to segment GD, and that angle ACD is congruent to FDC. Those two angles. All right, so that's your given. Okay? So I'm going to use a pencil here, actually, because it's going to kind of help a little bit, because this is a big chart. So GC is congruent to GD, and ACD is congruent to FDC. So that's including the sum of these corner angles right here. So it's the sum of these two that are congruent. Both of these, and the larger angle, I guess you could say. So where could we go from here? I will tell you this is 4 steps. But where could we go from here, do you think? Knowing that these two sides are congruent.
Or it makes sense like isosceles and a triangle. So C and D are congruent angles.
Mm-hmm. C and D are congruent angles. Yep. So the way I'd express that is probably angle GCD is congruent to angle GDC because of the isosceles triangle theorem.
What were the angles?
GCD and GDC. So it's this smaller angle here and this smaller angle here that are congruent. These two.
So,
So where could we go next?
could you say, since those angles are the same, equal BCG and EDG? Or no?
So actually, no, could not say that. However, remember what you're trying to prove here. You are trying to prove that this triangle is congruent to this triangle.
We have an angle on the side. Oh wait.
You actually do have an angle and a side, right? Because this side is congruent to itself. This side is shared by both triangles. So,
What CZ is congruent to CD?
correct. And that is just simply the reflexive property.
And then you can figure, and then you know that that's equal to each other because of angle, side,
Correct.
side, angle, side.
Yep. Or angle side angle, actually.
Wait, how is the angle?
Because it's the larger angle here, this side here, and then this angle here.
Wait, but I thought, well, wait.
Yep, BCD is congruent to triangle EDC. And that is by angle side angle. Questions on that one? Emily, you look very...
It's something.
It's something? It is something. That's for sure. Again, this will give you an idea of kind of what the proofs you'll expect on the test too. So, I think there's going to be like 2, maybe. Alrighty, next I'm going to fold this down because I need more room. Alright, we are on to number 32. 32 right here. So this is asking you to match each right triangle congruence theorem with its equivalent general triangle congruence theorem or postulate. So again, basically comparing right triangles to regular triangles in terms of their congruence theorems. So think about leg-leg, for example. Leg-leg means that on a right triangle you have 2 legs congruent. What is that similar to?
Isosceles?
Well, it is an isosceles triangle, yes.
Oh.
Side angle side.
Yeah.
Yes, that is correct. Okay, so leg-leg is the same as side angle side. Right?
Yep.
So what about leg angle? So what that one looks like is you have a right triangle. You have an angle, a leg, another angle. What does that look like to you? That one right there.
Angle, side, angle.
Yes. Exactly. Yep. And then the next one that we have here is hypotenuse angle. So that means the triangle is going to look something like this. The hypotenuse is right here, and your angle is right here.
You can't see it because of the recording thing.
Oh, okay. Here, let me move this up a little bit. There. So which one does that match up with, you think?
Angle, side?
Angle, angle, side. Yep.
This just goes in order.
Pretty much. And then lastly, hypotenuse leg. Because you have your hypotenuse and then you have your leg. What does that one match up with?
Doesn't it not match up with any of them?
Correct. It does not match up with any of them. Because the only way that this works is by the fact that it is a right triangle. If you had another side-side angle triangle, it could not feasibly be proven to be congruent with another triangle. All right. Does that make sense? Questions on these?
That makes sense.
Okay. Sweet. So, number 39 is the next one, which I believe is right. Yeah. So, I'm going to flip this again. Number 39. you're trying to find the measure of angle UVW given this figure. So the angle that we're looking for here is this one. UVW. That's your angle. What do you think the measure of that angle could be? April?
Well, isn't it 44 degrees?
Yes. Why, though?
So when you like flip it, and then, because this is like upside down, which is the normal angle. So once you flip it back into its place,
Mm-hmm.
that UVW is the same thing as, is it TRS?
Yes, TRS. Yep, so again, this is just a flipped around similar triangle compared to this one when you connect the mixed segments. So that means these two opposite angles would be in fact congruent. Yep. Alrighty. So number 40.
Wait, hold on.
Okay, freeze frame, what you got?
Is it B because it's in the middle of the two letters? So we're trying to find
Yes,
Okay. I was trying to figure out why it was.
that's correct. Yep, that's why it would be V. Alright, and then number 40 is we're asking for RS. So to find RS, what do we need to do? Yep.
Wouldn't it be 5?
Yes, why would it be 5?
Well, because if you flip it around again, VW is always half of that side.
Yep,
And so since it's 2.5, that's both sides going to be 5.
yep. Yeah, so again, 5 is the opposite, or 2.5 is the opposite mid-segment that's not touching this. So that means it'd be double. So that's right. That means RS equals 5. And that's the whole chapter review.
Wow.
That's all we did for this one. Okay? But do you guys want to work on some additional problems?